In this video, we'll talk about the relative motion. We'll know what is motion. Actually, motion is a state of moving. So, relative motion, we'll know about it, and the concept of relative motion, we'll talk about it in this video. Now, the meaning of relative motion. Relative motion, this is the motion of a body relative to the moving observer. So if the observer is moving and you observe the motion of the other body, so we can directly say that that's relative motion. Now the relative velocity of two bodies, we'll talk about that as relating to relative motion. As motion, there is kind of we can say the velocity, and because the motion, it means that they're moving, so the moving can have some kind of a velocity. So we'll talk about the velocity that is relative to the observer. In the first case example, if a bus is overtaking another, a passenger or observer in the slower bus sees the overtaking bus as moving with the very small velocity. So if, for example, an observer is traveling in this bus A, and the other bus that is overtaking bus A, so the observer from bus A will see the overtaking bus not moving much faster as if the observer could have been stationed in one place. So a motion of that bus relative to the observer, you can observe that there is a relative velocity among the two moving objects. The second case is that if the passenger was in a stationary bus, then the velocity of the overtaking bus would appear to be greater. Now, in this case, you see that there is a difference compared to the first case, as the first case, both of the two buses, they were moving, but the other, which was being taken, had a lower velocity. But in this case, the second case is that the passenger, who is to be an observer, is in the stationary bus. Now the velocity of that bus that is passing through that bus will appear more greater than if that bus was also moving at any certain velocity. So that's the second case. Now the third case is that if the observer is not stationary, then you find the velocity of a body B relative to body A, we add the velocity of B to A. So if the observer is not stationary, talking about the example in the first case, so then the velocity of body B relative to body A, it means that you add the velocity of B to A to know exactly how is the motion of that body. So the relative motion of two bodies, we talk more about if velocity of body A is let it maybe VB and the body of A is VA, then the velocity of B relative to A, the relative velocity VBA is given by, it means that you will add. Now, as you see that it will be VA equals to VBA equals to VB plus, as the other one in the body has a negative velocity, so that's going to make it that VBA is equal to VB minus VA. Note that the relative velocity can be obtained graphically by applying the triangle and the parallelogram method. This we have already talked in the other video. For the same direction, the first case was as B relative to A. Now let's talk more that for the same direction, these two. So velocity BA will be VB minus, it means that the first one, velocity of the bus A or of the body A was moving in the other direction compared to body B. Now if the both of these two, that the body B and the body A, are moving in the same direction, so if you apply the formula, it will be VBA will be equal to VB minus VA. Now for a different direction, it means that the subtraction sign will make the equation there to be VB plus VA. I hope it's clear. Now let's talk on the concept of relative motion in daily life. So we'll see how is relative motion used in our daily life. The first one is that the frictional force is determined by the relative motion between the surfaces in contact. So if you see there is a frictional force between the two surfaces, there will be the determination of the relative motion between the surfaces in contact. So that's the basic case you can observe in our daily life, and we might know how the frictional force is used in our daily life to the various applications. Example, assisting the movement of various bodies. Example, even us when we are walking. Now, the second one is that relative motion of planets around the sun causes the outer planets to appear as if they are moving backwards relative to the stars in the universe. So this is the application, and it's the concept of relative motion relating to the solar system. And the third one is that in everyday life, when we measure velocity of an object, so example, when you are trying to measure velocity of an object, how is this body move? I mean the velocity. What is its velocity? We will determine it by through also the concept of relative motion, like the measuring or the observing object, is it stationary or relatively moving. So that's all for this video. I hope it's clear. We've talked about the relative velocity of two bodies and the concept. We've talked first on the meaning of relative motion, the relative velocity of two bodies, various cases we've seen them, and there are various formulas, and we've seen the concept of relative motion in daily life. Thank you for listening. Stay tuned to other videos.